Okay. How many pieces does this function have? 3. So let's do the left one first. I'm going to color it blue. Now, for linear pieces, I always start with the mx plus b form, just because my brain works better like that. Some people do transformation form with an HK. That just doesn't work well for me, so I always do it this way. However, you're welcome to do it that way. I just do some quick math to make sure we have the same thing, because with the HK form, I just have to distribute and then combine like terms to see if it matches mine. But here's how I do this with the mx plus b. The first thing I do is figure out the slope. So I pick 2 points on there. So I'm going to pick the open circle and the point at the tip of the arrow. And to do slope, you just have to figure out your rise over run. So rise is down 3, and the run is over 2. So rise over run means the slope is negative 3 halves. If you do the other way, you get the same thing. Let's say, which dot did you go to? Which one did you start with? From here, or from the white one? From this one? So this would be up 3, but left 2, so it's still a negative 3 over 2. Because 3 over negative 2 and negative 3 over positive 2 are the same. And then for the y-intercept, I would just use the slope, just a counting pattern until I found where it should have intersected the y-axis, but it's been cut off. So I would start at the open circle, I would go down 3, right 2, and see that it hits there. This is a distraction, but you got a good deal on it. But we're just going to leave it here till a little bit later, okay? So the y-intercept is 0, so we don't have to write 0, okay? So we're just going to leave it like that. So negative 3 halves x. Did anybody write their linear piece in transformation form? Because I would like to show everyone what it looks like. Nobody? Okay. And then here's the domain piece. The left boundary is negative infinity because of that arrowhead. And what's the right boundary for the domain? What is it on the right? X equals negative 2. Is this included or excluded? Excluded. How'd you know that? Because the open circle, right? It wasn't filled in. Yes. So who's got that right so far? All right, very good. So the middle piece, which we're going to do in red, what is that parent function? What does that look like? Cube root, right? Cube root. So the general form for that looks like this. Where do we get the HK from? Do you remember the special name for their point on the cube root? Starts with an I. Inflection point. Okay, it's the inflection point. It's right here. So you need the ordered pair right there. So it's 2, 3. And that goes in for your HK. That's your H. That's your K. So you plug it in. Plug it in, plug it in. So then you need to figure out if it has an A value. The A value is made up of 2 things, whether it's positive or negative, and whether there was whether the y's got multiplied by anything. So we know that A is not negative because it didn't flip over the y-axis. It's still in its original position, just moved. And then here's how you figure out if the A has changed. Just test out your parent points. Like this one has a point at 1, 1, or negative 1, negative 1. And if it's still there, then it hasn't changed at all. So if I go here to the inflection point, if I go over 1, up 1, well, that still has that point there. Or if you went the other direction, down 1, left 1, the point is still on the graph. That means the y values haven't changed at all, so the a is still just 1. And so it's not negative, it's still 1, so we don't have to add anything there for a. So this is our equation piece. The cube root of x minus 2 plus 3, and then we just need the domain restriction. What's the left boundary here? -2. And it's included. Very good. So -2 is included. That means it gets an equal bar. And then we need all the x's between that and excluded 3. Thank you. And so I put that over here. Questions so far? Concerns? The last piece is what kind of parent function? Not absolute value. It has a little curve. Yeah, it's a square root. So there's the basic form. You figure out your HK by seeing where the initial point translated to. So it's right here at 3, 3. That's your HK. So I'm going to plug that in here. And then A has 2 parts. The first question, is A negative? Yes. How do we know A is negative? Because the graph did what? Yeah, it flipped. It's going down instead of up. So A is negative. So then we just need to know if the y value got multiplied by anything. So since it's flipped over, if there's no A stretch or compress, whatever I'm trying to say, it should just go down 1 over 1. And it does. So A didn't change at all except for being negative. So then this is my function piece. And the domain restriction is the left boundary, which is 3, included, because the circle is closed, to 7 excluded, because the circle is open. Open, open, open. Questions about that? What are we doing in class tomorrow? Quiz over Friday's material, which was this, and Thursday's material, which you can have a skill check on right now. Oh, any homework questions? Skill check. So get out 2.7, evaluating and graphing piecewise function. That's from Thursday. Please and thank you.